this question, we have the equation of a curve and where m is a constant and the equation of a line is y is equal to 6x plus 4. We have to show that for all values of m, the line intersects the curve at two distinct points. Now, whenever we have an unknown constant in an equation, we always use a discriminant, which is b squared minus 4ac to find that value. However, in this case, we just have to show that for the values of m, the line is intersecting at two distinct points, which means that this equation must be greater than 0. So to form this equation, first we'll equate the equation of the curve and the equation of the line. So we get 2x squared plus m into 2x plus 1 is equals to the equation of the line, which is 6x plus 4. Now simplifying this, we get 2x squared plus 2mx minus 6x plus m minus 4 is equals to 0. So from here, we can reduce that a is equals to 2. B is the coefficient of x. So in this case, that will be 2m minus 6. If we take x common from over here, we will get 2m minus 6 as the coefficient, and c would be m minus 4. Now, putting this up in the equation b squared minus 4ac, we have 2m minus 6 whole squared minus 4 into a, which is 2, and c, which is m minus 4, and this is greater than 0. So expanding this, we get 4m squared plus 20 minus 24m plus 36 minus 8m plus 4 2s are 8 times 4, 32. Simplifying, we get 4m squared minus 32m plus 32 plus 36, which will become 68, is greater than 0. Simplifying, we get m squared, so we can divide the whole equation by 4. We get m squared minus 8m plus 17 is greater than 0. Now we have to show that this equation is greater than 0, which means that if we make the x-axis, below it is the negative part and above it is the positive part. So we have to show that this equation lies above the x-axis or it is greater than 0. We can do that by finding the turning point of this curve. So we find the turning point by converting our equation in the form y is equals to a into x minus h whole squared plus k. In this case, our variable is m instead of x. So to convert this into the full square form and then finding the turning points, because by finding the turning points, we'll be able to prove that the whole equation, whole curve lies above the x-axis. So expanding this, we have y is equals to ax square minus. Okay, so what we can do is, first of all, we can just expand the bracket. So we get a multiplied by x square minus 2xh plus h square plus k, which will become ax square minus 2axh plus ah square plus k. Now, to avoid any confusion, we can just use a variable m instead of x over here, or in this equation, we can use a variable x. So to find the values of a, h, and k, we can compare the equations that we have. So this is the form of the full squared form, and this is the equation that we have, which is m square minus 8m plus 17. From this, we can deduce that a is equals to 1 because that is the coefficient of m squared. The coefficient of m over here is minus 2ah, which is equals to minus 8. And the constant is ah square plus k, which is equals to 7. So as a is 1, so minus 2 times 1 is minus 2. So h will become minus 8 upon minus 2, which is positive 4. And now substituting a and h over here, we get 1 into 4 squared plus k is equals to 7. So this will become k is equals to 7 minus 16, which will become k is equals to minus 9. Okay. So, okay, so this is not 7, this was 17. So 17 minus 16 would become a positive 1. Now putting this up in the form y is equals to, so we have a as 1, x minus 4 whole squared plus 1. From here we can show that the turning point of this curve is 4 comma 1, which is basically above the x-axis. So it has a minimum point. As a is greater than 0, it means the minimum point is above the x-axis. As this point is 4 comma 1, it means the curve can never go below the point y is equals to positive 1. So we can, so this is how we prove that the whole curve is above the x-axis. And this is basically how we show that for all values of m, the line intersects the curve at two distinct points. So we had to prove that this whole curve is above the x-axis or greater than 0.